Hello, Precalculus student. This video is for chapter 3.3, part 1. No, part 2. In part 1, we talk about power functions and we discuss how they look like in terms of the end behavior. So they actually only have 4 shapes in terms of like how it look like. So there is this shapes where it goes up and up, right? If it is an even degree and positive coefficient, or it goes down and down if it is even degree but negative coefficient. It can go down and then up. If it is odd degree but positive coefficient, and then it is down up on the left and then down on the right if it is odd degree but negative coefficient. So these are the shapes of a power function that has only one term. Now we're looking at the general polynomial functions. Polynomial means more than one terms, poly, right? So a general one would be like this: an x to the n plus a2 x to the 2 plus all the way to a2 x to the 2, like that an minus 1, and then plus a0. So that means there's n terms. Actually n plus 1 terms. So it might have x to the 1, x to the 2, but it would have an x to the n with the highest degree. So this is called the degree of the term, and this is the coefficient of the term, and the one with the highest degree is also called the leading term, and this degree is the degree of the whole polynomial. So this n would be the degree of this term and also the degree of the whole polynomial. And this particular coefficient, we call it the leading coefficient. The term itself is called the leading term. Now, when I write this polynomial, I write the leading term as the first one. That's the convention. Write them in descending order of x, of the degree of x. But this term can be written anywhere. So a leading term does not necessarily to be in the first term. It could be in the middle. So anyway, so you look at all the degree of all the terms, the degrees of all the term. The one with the highest degree is the degree of the polynomial. Okay, so basically it's like that. So for example, an example would be f of x equal to 3x to the 5 plus 4x to the 4 plus 2x plus 1. So the highest degree of the whole polynomial will be x to the 5. So this term is degree 5. And it has the highest degree out of all this because this is degree 4 and this is degree 1. And so this is called the leading term. And 3 would be the leading coefficient. 5 is the degree of the whole polynomial. Okay, so we don't add degrees together to get the degree of the polynomial. Degree of the polynomial is the degree of the leading term. So that is some terms and features of a polynomial formula. What about graph? If you look at a graph, how do I know it is a polynomial graph? So there are 3 features that we can pay attention to. One is when you graph a formula like this, it's always continuous and there's always no break. There's no holes, no gaps. So it always connects together in one piece. So end behavior is always approaching infinity or negative infinity. It never like fell flat. It doesn't flat out. C is the turning points are smooth. So if they turns, there's no sharp turns. Okay, so for example, this would be a polynomial function, can be modeled by polynomial function. So because at the end behavior, it goes to infinity, and then the turns are smooth and there's no breaks, no holes or gaps or anything. The second one cannot be because there is turns, they go to infinity, that's good, the end behavior matches, but there's turns, sharp turns. This is sharp turn, so it's not a polynomial function. So this is yes. And what about this? So there are some turns, they goes to infinity on one side, negative infinity on the other side, and they're all smooth turns, and this is good. What about this? They go to infinity, they have, turns, but there's gaps here. So this is not. Okay. So polynomial functions are very nice. It's continuous and smooth. You can say like two description that describe it is continuous and smooth. And then there are other characteristic of a polynomial function of degree n. So if I know a polynomial function, its highest degree is degree n, then what can I say about the graph itself? So there's some connection between the graph and the formula. First is a graph consists of turning points and end behaviors that go to positive and negative infinity. The end behavior is determined by the leading term only. So whether it goes to positive or negative has nothing to do with the second term or terms that are lower degree. The leading term itself actually control the end behavior. So if you want to know the end behavior of a polynomial function, like these, whether it goes up, down, you only look at the leading term. Second one is you can see that polynomial function may have intercepts, right? So there's one well, this one is not. There's a intercept here, there's a intercept here. This one has 3 intercepts. So if you look at the degree and the intercept, they're kind of related in that for a n degree polynomial, you at most have only n x-intercept. So if it is degree 3, you maximum can have 3 intercepts. You can have less. So like quadratic functions, degree 2, the most intercept you can have is 2. If you are degree 5, the most that you can have is 5. So etc. etc. So you can have less, but you cannot have more than n x-intercept. The next one, the fourth one is when they turn, how many turning points can they be? At most, you only can have n minus 1 turning point if it is degree n. So if it's degree 3, you can only turn 2 times. So like, for example, this may be degree 3 because I can see that it turns 2 times, right? And then the next one is if I see a graph. So this is if you know the degree. Okay, if you know the graph and you see m turning points, what would be the degree? So if it has m turning points, we know that it has a degree n. Polynomial can have at most n minus 1 turning point. So if you have m turning point, so you would have at least n plus 1 degree. So if something turned 2 times like that, so at least is degree 3, right? At least degree 3. It could be degree 5, it could be degree 7, but at least degree 3. So m turning point will be at least degree m plus 1. What about k-intercept? So if a polynomial function has k-intercept, it would be at least degree k. It could be more. At least means it could be more, but at least it's degree k. Okay, so we talk about turning point. What is a turning point? Can I say this is a turning point like the x to the third, right? This kind. It seems like it's turned a little bit, right? But no, this is not a turning point. A turning point has to be a point where it rises from the increasing to decreasing or decreasing to increasing. It actually change and like it's like a bends back or bends up. Okay, so these like a little rest, like a twist, is not a turning point. So that's how we relate a polynomial function's degree, like the formula and graph. So let's do some example first. I have a polynomial function, right? I have a formula. I want to find out the end behavior. So what is the leading terms? Is the first one? No, not this one. This is not a leading term because the leading term has to be the one with the highest degree. So this is the leading term because it's degree 3, right? So in this leading term, I would just look at a power function of 4x to the third. Do you remember what end behavior we have for y equal to 4x to the third? This is an odd degree, and it is a positive coefficient. So the end behavior would be drop to the left, rise to the right, right? So it would be like this. So the end behavior would be the same as this whole thing. It has all these other minus 4x, it even have an x squared, but does not influence the whole behavior of the end behavior. The end behavior is primarily determined by the leading term. So we would say when x approaches infinity, f of x still approach infinity. When x approaches negative infinity, f of x approaches negative infinity. So negative infinity means the left side. Another one, so we have this polynomial function 3x to the 5th plus 3x to the 4th, blah, 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 plus 7x plus 1. We don't even write this. So we notice that, well, we assume that this is in descending order. So this would be the leading term, right? It's power 5 or degree 5. This term is degree 5. This term's coefficient is 3. But what about this one, 3x to the 4th? It is this one. The second one is degree 4. Coefficient is 3. But the leading term is not 3x to the 4th, is 3x to the 5. One more s. So the degree of the whole f of x is just degree 5. Okay, the highest degree belongs, or it can be used to describe it. Why? Well, the leading coefficient is also 3 because this term has a 3 as a coefficient. Now, because it's degree 5, how many turning points can it has? If it is degree 5, it would have 4 turning points. It's always one less than its degree. What is the most x-intercept that it can have? Most it can have is exactly the same as the degree 5. So 4 turning point 5. Okay. The end behavior. So let's check the end behavior because x to the 3, x to the 5, we can think of it the same. Oh, x to the 5. It's the same as this particular end behavior. So odd and then positive, so it's the same as what we have last time. So it would be down and then up like that. So we say x approaches infinity, f of x approaches infinity. When x approaches negative infinity, f of x also approaches negative infinity. Okay, so this is the two examples that relay graph and the formula. One more. So this one is a little different. So they are not written out, filing out in terms, but they're all like multiplied together as products. So how can I find the leading terms? The leading term actually can be found by selecting the highest degree in each one of these, products. So for the first one, we see 2x, right? So we can just multiply only the x term. 2x. What about x minus 4? What would be the highest term? So the highest x term would be x squared, because when we FOIL x minus 4 squared, it becomes x squared. So times x squared. Just to get that one because we only want one term. Then this one has a x squared term, so I times x squared also. So this would be 2x to the 5. So the leading term is 2x to the 5. Oh, well, it's the same as this. The end behavior what? So it's the same as y equal to 2x to the 5, same as the power function. So power function of odd and then positive is the same. I should do other example. But so that we would say when x approaches infinity, f of x approaches infinity. When x approaches negative infinity, f of x approaches negative infinity. So this is the section that relay features of a polynomial formula and the features of the polynomial graph. Notice how we can use the formula to find some features of the end behavior by looking at the leading term.